Today with me is Haroen, our CTO and founder. And we are actually going to run a really fun session because, as many of you noticed, we worked on a World Cup predictor just in time for the biggest ever World Cup in history. So there are lots of scenarios that are playing out and will be playing out in the next month or so. And Haroon today will tell us what it took him to actually build this World Cup simulator. And we're going to discuss a lot of really interesting things because personally, I'm really curious to learn all about what it takes to take a pretty massive data set and build something really interesting with it, with scenario planning and something that can actually tell us who's going to win the World Cup. So, Haroon, the floor is yours. Please tell us a little bit about the project that you worked on and tell us what it took to actually put it together behind the scenes.
Thank you, Lena. Thanks also for organizing this. Let me first share what we are talking about here today. So about 2 years ago, for the Euro 2024 football tournament, we built the first version of a prediction model where, for each of the teams and matchups, we gathered a lot of statistics on the number of corners and other stats that the players have been taking, and letting an AI octopus predict and comment on the expected results. And we thought we want to do that again, but at a larger scale now. And that is what became the What If simulator. So for this tournament, for World Cup 2026 being organized in the USA, in Mexico, and in Canada, we've done the same thing. And so we are currently after the first day of playing day of games. We currently predict France to win in the final against England, and Argentina to lose for the third place match against Spain. Now, what is different this time is that you can change any of our assumptions and just run out the entire tournament again. So it could be discounting certain teams, or what would happen if you remove a certain player from a squad, or what if a certain team doesn't have to travel as much, and you can quantify what the impact of those changes is. So let me try that here. What if the USA team can actually field any player that's playing in the MLS, so the National Football League in the US. So instead of having to be a US national, US citizen, they could field any player. So what we do is translate that to a scenario and then run that scenario through the exact same forecast model that our baseline scenario, the scenario that we think is most likely. And so what do we see? Fielding any MLS player lifts USA to the Group D win. And we think, let me see where they are. We think that they actually make the semifinals now and lose against France. And here in the probability table, we see that they've jumped up to third place overall in probabilities by having access to that quality player pool. You see that USA has the largest impact here. It has a plus 11% change versus the baseline scenario. And so the question is, how did we build this? And that's what I'm going to tell you today. So how does this actually work? Well, it starts with predictions for individual games. Tonight, in about, 2 hours and a half, we'll have the USA kicking off for a second time against Australia. And we believe the US to have a 55% chance of winning this game, and we expect a representative scoreline of a 1-0. So how is this calculated? For each of the teams, we have been gathering a lot of statistics and data. Like the data sets that you usually have in your Luzmo environment. And so for this particular tournament, we are using data from a football API, and this involves really squad level details on all the selected players for each squad and their performances over the past 2 years of playing, both for the national teams and for clubs for their regular club plays. So think about number of saves, number of passes and pass accuracy, number of clearances made, number of assists given, number of goals scored, etc. So different stats for each position. What we do then is calculate a expected number of played minutes for each player, depending on at this point for the first match or the second match, fatigue that they have incurred so far in the tournament, and also their injury status, and calculate like a global offensive and defensive score for each of the teams. And we do that with a kind of weakest link model. So for a defense, we expect that the player who is rated worst in defensive skills as part of a defensive position, that their skill weighs through a little bit more, because you can score against a team if there's one weak link in the defense. And vice versa, on the offense side, we rate the strongest player, we weight them a little bit more in the overall offensive score, because we just need a flash of genius. And so these scores are compared, and depending on lots of World Cup games that have been played in the past, we can estimate an XG score, so expected number of goals. This is like a statistical metric that says over many games, if you have an XG of 2, means you will score on average 2 goals for your side overall of these games. That doesn't mean that you'll always score 2, of course. This is a probability distribution, and from that distribution, many different scores might appear. Now, once we want to go from these individual games to entire tournaments, it becomes a little bit more complicated. And I'll try to explain it here. So while our normal games can still be modeled by a probability distribution. So, for example, the strength of teams can usually be described with like a normal curve, a bell curve, a Gauss distribution. You might have other parameters that are just a uniform distribution. Every outcome is as likely. This is our likelihood. Or we might have something like an exponential or Poisson distribution. This is usually for number of goals. Scoring 9 goals, 10 goals is possible, but is very unlikely. So this approach is 0, but is never entirely 0. For an entire tournament, it's impossible to really draw from or describe it with a single probability distribution, just because the number of factors is so large. There are so many nonlinear effects. The rules for who qualifies as a third place team to go through in the final bracket, that's extremely complicated. And so it turns out that one of the best ways to actually draw probabilities and estimate those probabilities of such a complicated statistical setup is by just playing it out. So what do? We built or we ported our calculation engine, our simulation engine that we built for Euro 2024, which took about 5 to 10 minutes to run a full tournament prediction with 5 to 10,000 iterations. We ported that to Rust, so the same technology that is behind our query engine. And now we can actually simulate 5,000 tournaments, so 104 games, 5,000 times, and simulate a lot of effects within 2 seconds, which makes it feasible to run this interactively on demand by a user when they describe the scenario. Before I dive into some of the nuts and bolts of this simulations, so this is a Monte Carlo simulation named for the casino.
Sure. First, when you initially shared this link with the team for some internal testing, we were, I think, at around 5 million simulation runs. So can you tell me a little bit about the number of runs that you need to do to get to statistical significance? And if it actually matters how many times the simulation is run, does it impact the outcome?
Yeah. No, that's a very good question. So why have we taken 5,000, for example? So what you see if you run this Monte Carlo simulation, so let's say I have here my number of iterations, and here I'm looking at something like the standard deviation. So how much variance there is from run to run. What you see usually is that there's a lot of variance. There's a lot of variance at the beginning, and you see it drop down, and eventually it sort of plateaus. Oh, it sort of plateaus, and there might be some residual variance, just because, especially football is a very uncertain game where upsets are quite likely. So there will be residual variance, but you'll see that the variance will remain static after, for example, 1,000, 2,000 runs. In this case, we initially ran only 1,000 runs, but we saw that the variance was between different runs was still too high. And so 5,000 is like a good balance between not spending too much computational time versus having results that actually saturate and settle down to a stable number. But the right number depends on the model that you run. So you run a Monte Carlo simulation on a very complex process with lots of parameters. It might take a longer time for this to settle. You might need 100,000 runs, 1,000,000 runs. That depends, but you can look at the error curve and see when it optimizes. You could even have a dynamic number of simulation runs where you only stop if your run-to-run variance has become low enough, for example.
Got it. And another question is around the data set. You initially launched this simulator a couple of days before the World Cup started. So there was a lot of room for speculation and different scenarios that we could run. We are now a few days in the group stage, so results are in. Is it a live data set? And if I run a simulation on June 21st, will it be different from the one that I ran on June 10th, for example? And how does it work?
Yeah. So indeed, there are many factors that go into the model. And many of these also change during the tournament as we get more and more information on the actual team strength and their current morale and things like that. So what currently goes into the model is like a national team strength parameter that is using an ELO rating. This is like a FIFA rating. It takes into account it comes from the chess world, ELO, and it takes into account the results of matchups between different countries and their relative strength against each other. So if you win against a very low-rated opponent, that won't change the rating much. But if you, for example, draw against a very equally rated opponent, there might be a larger difference. We also incorporate the squad level statistics, player level statistics. Some models, football models, only use these ratings. Some only use these ratings. We chose a blend of about 40-60% influence because this makes for more interesting scenarios that you can actually play out. If we would have not included player quality, you couldn't do a switch like what if players playing in the MLS are involved. The system would have to directly estimate what that would do to the ELO rating, so less, a more uncertain scenario than if we can actually swap the actual players from team to team. We have their injury data, we have the locations where each of the teams has their base camp and the travel distances. And that is especially important this World Cup because some matches are being played above 2,000 meters of altitude. Mexico City is up very high on a plateau, and there's less oxygen in the air. You need acclimatization to play at that altitude. So teams, especially later in the World Cup, who are not conditioned for that, might get a performance penalty to them. We also see, the host nation, of course, has a big advantage because they get a lot of local support and want to shine, so that affects it. And we take into account heat and altitude. So all of the stats are being updated continuously, and the source data changes. So we rate Spain, for example, lower now that they have drawn against Cabo Verde, and that has actually caused France to become in the baseline scenario the top performer now. But all of this data is not encoded into the model; it's just treated as an input to the calculation engine, and that means that you can change any of these parameters yourself. Like you could ask to fully remove fatigue level effects, and then we will override that parameter and set that effect to 0. Or you can change other things to this. The data itself is updated every day. So the ELO ratings are updated. The player data is updated. If a player would drop out, for example, with an injury, that is taken into account for the baseline scenario. But for example, also the outcomes of the games themselves are being loaded, so that as the tournament goes on, we should get more and more accurate about predicting who will actually win it in the end.
That was super helpful. Thanks for the explanation. Please go ahead and tell us a little bit about what's under the hood and how this simulator came together.
Yeah. So next part that I definitely want to talk about is so we talked about the data, we talked about how we got here, we talked about the effects that actually go into the simulation, about the Monte Carlo simulator, but how to link this up together to make this a what-if scenario analysis. So here we built a small AI agent that has access to a number of different tools to make this application work. And the first one can take a what-if question and translate it to a scenario. And how that actually works is that the calculation itself, engine itself, receives a number of inputs. For example, the squad level details, the player level data in detail with all the statistics for each of the players, all of the effects, like how many goals we expect for a certain matchup between an offensive and a defensive ability, but also the base camp locations, and even the playing dates and the schedule itself, because that can influence the tournament. And we also want you to be able to adapt even those things. What if the World Cup was organized over a period of 2 months? Perhaps other teams would be, would rise to the top here if they only would have more resting time. Imagine teams that have a less deep squad. Teams like France or Spain, they have an entire bench full of world-class players, but some smaller nations don't have that, and they would benefit from playing the World Cup over longer periods of time. So how we do that is we ask an LLM, in this case it's an OpenAI model, to translate the what-if scenario into a scenario patch. So really just a JSON that describes only the changes to the source data. Then we merge in that change into the main data. And then the agent can ask to run a prediction using the Rust-based calculation engine. That then results in a lot of output data, the probability table, but also the individual outcomes of games, and other types of statistics. And then there is a tool called that can compare the baseline data artifacts with the artifacts that are being generated for a certain scenario that we explored with the MLS players. And then finally, there's a tool called to write a summary and give a good explanation of like the headline results of the scenario, like what changes. Is there a new favorite for a World Cup win, and how does their bracket look like? How does their path to victory look like? And then finally, there is a tool call that can answer any questions that you might have about these scenarios. So here we are also swapping players in the MLS. You see that with USA's MLS eligible pool, we flip Group D. and you can ask questions. So we added 2 questions here: which games shift most? And so it says that the biggest swings are USA versus Australia, and then USA versus Turkey, where the win probabilities, for example, jump a lot. But you can ask to show really the actual JSON change that was made, because the agent has access to that information. Okay, so in this case, there were player updates. So 13 named players were moved into the squad, and the morale was also updated, for example. And so you can ask questions around the results, around individual game results. For example, what are Belgium's scores in this scenario and their tournament progression? But also in this scenario, Belgium finishes first in Group G, 7 points, 2 wins, 1 draw, 0 losses. And then in this scenario, we actually lose to the USA in a kind of World Cup rematch versus a very interesting match that has been played in the past. So by giving the agent these options and the right data, you can get to very interesting results without even thinking through all the possibilities that this app should have. It's really to the users to make this fun and actually find the limitations of what's possible.
Having such a data set is definitely a privilege because there is a lot to dig into. There's so many different probabilities. So I want to ask you if you think the same approach is feasible for a smaller data set, because clearly various products have diverse data sets, but not probably as vast as this one that you were working with. So maybe you have a recommendation for the minimal viable data set, or your perspective is that you can make it work on pretty much any data set with the right approach.
Mm-hmm. Yeah. So that's actually the interesting part. That is that this data set is not huge. There haven't been so many World Cups, especially comparing that kind of training data to the training data needed to train a language model. There are also no parts of this data set that have probabilities in them. We only know the outcomes of previous games. We know the current player build-ups, etc. The part where the probabilities come out is by putting that through a kind of model that we build that describes what can happen during the tournament, and then by fluctuating the inputs. So you can do this, with any data set. Imagine that you have data sets on, let's say, energy efficiency of buildings, and you're calculating, and you have a calculation engine that calculates, for example, the total CO2 emissions of a building. You can do something like this. Like, what if that building would be heated in a different way? What if that building were not used for a couple of days a week, or were more intensively used? And the LLM can make scenario patches, change the data set, rerun the scenario. Or another very interesting thing that almost any company can do is do sensitivity analysis. So there is some data. We are showing some results to end users about the slicing and dicing that information. But what if certain input parameters are slightly changing? What if your client has slightly less revenue or slightly more revenue? What would that mean for their profit margin, for example? And that can really elevate even a small data set and make it much more valuable by doing those transformations to the data and showing the end results to the user, because they have more of an idea of how stable the results are, get more trust in your data if you can actually show probability distributions and uncertainty factors that have been really calculated through.
Thank you for this. As a marketer, I would love to build such websites for the customers, left and right, maybe a few times during the quarter, because it's an engaging way to showcase the data and also demonstrate the capabilities of your product. And we've had quite a few eyeballs on this World Cup simulator. So it looks like a really exciting project. On the other hand, even though we are in the age of AI, it still seems like a pretty significant undertaking. So, really curious how long it took you to put something like that together. Was it, weeks and months of preparation, or actually something that you worked on in a matter of a few days?
Mhm. Yeah, so I think the time from the initial idea to take the Euro predictor, turn it into a World Cup predictor, and add what if scenarios just took 5 days or so, with a combination of AI coding that makes it so fast to ship a new product now, and yeah, a good engine to make these calculations and visualize the end results. So this does not have to take much time. I think especially World Cup data is of course quite public data, but the proprietary data that you might have, yeah, you can do a lot of things with it by slightly manipulating it, adding forecast, for example, also providing benchmark insights. Usually, our clients only show their clients' own data to them. But it can be very interesting to also anonymize and process and aggregate all other data and see where a client actually fits in, if they are among the top 10% or top 40 or top 70%, according to some metrics. Yeah, many clients might be even willing to pay something extra for this to get that additional level of insight that they otherwise cannot have.
Yes, and I think this can be a really good inspiration for pretty much everyone, because if you have a product and if you own an audience, this means that you already have some interesting data points that your customers can benefit from exploring, or maybe just have a little bit of fun with it. And I think what everyone can appreciate here is also the flexibility, because I think we are very used to working with predetermined dashboards and data sets that we cannot manipulate. And something that makes this experience so fun and interactive is the fact that you're absolutely not limited with the angles that you can take to explore the data. And you will still, at the end, get a simulation and a result that you're looking forward to. So I think that's a really engaging way to present pretty much any data set.
Mhm.
And if we were to recap, maybe you can share a few recommendations in terms of how one should approach this type of project, how to pick a data set, how to come up with V1 of approach to exploring it, and maybe some other tips and tricks that you realized while you were building this.
So what I think is definitely take a look at all the data sets that you have, that are available, and take a second look at them. Like, are there some of your sets that could actually be more valuable by applying a sensitivity analysis, a benchmark, a prediction model to it? It can be an auto-regressive forecast, or a system like this, a model-based forecast. And try to build a small application around it, release it to clients, and then get into a feedback loop, because that's always the most important part. The initial version of this was also lacking functionality. We didn't have most surprising scenarios. We didn't have the bracket visualized, and it's by feedback that apps like this become better and really answer questions that people have.
Thanks, Haroon. We're coming up on time, and I really appreciate you taking the time to first build this simulator. So we definitely encourage everyone,
Yes.
if you haven't done that yet, to check out this World Cup simulator. And thanks for sharing your perspective on how you can actually have a lot of fun with pretty much any data set. I'm really happy that we're past this concept that data is boring and it can only sit and live in multiple predetermined dashboards and data files. Thanks again, Haroon. Really fun session, and looking forward to more showcases of things that people build using Luzmo and visualizing their various data sets.
Perfect. Looking forward to that. Thanks, Lena.